So I've got a few examples today with polynomial algebra, specifically higher order polynomials. And these higher order polynomials are going to use a few different theorems. They're going to use a few different theorems. So what I want to do is I want to give you a few of these theorems as we go along, okay? So the first one's called the remainder theorem. Okay, and what the remainder theorem says, it's actually two parts. The first part of the remainder theorem says if you do synthetic division with this number, you get the same result as if you plug this number in for x. Okay, we don't really care about that right now. Here's the second thing it says. Okay, if the remainder is equal to 0, then this is a 0 of the function. Okay? That's what the remainder theorem says. So if I do division with this number on this polynomial, if I get a remainder of 0, that number is a 0. If I get any other number, it's not a 0. So what we want to do is we want to do synthetic division. So if you've never seen synthetic division before, I'm going to show you how it works. You're going to take the coefficient of each one of these guys. Okay, so that'll be a 2, 15, 14, minus 69, and minus 70. I'm going to draw a line there. I'm going to put a box here. This is our remainder, whatever goes in that box under that 70. Now, one more thing. The first number always gets copied. Okay, so I did that in blue, and I'm going to switch back to green. I am dividing by -5. X equals -5. So I'm dividing by -5. Now, synthetic division is real simple. We're going to multiply, then we're going to add. So -5 times 2, we're going to get -10. Now, add these two. -10 plus 15, you get 5. Okay? -5 times 5 is -25. You're going to add these two. All right, well, -25 plus 14 is going to give us -11. All right, so -5 times -11 is going to give me positive 55. Positive 55. All right, minus 69 plus 55. That's going to give me -14. Okay, and as luck would have it, -5 times -14 is positive 70, and -70 plus 70 is 0. So that leads us to a conclusion that x equals -5 is a 0 of the given function. Okay, so that's our conclusion. Okay, so that's the first one. You will get questions like this in a college algebra or a pre-calculus class. You also may see this coming from a calculus class because you're using algebra that's a prerequisite. Okay, so let me give you a second one. Okay, very, very similar. It's going to use a different theorem, and I'm going to talk about that theorem. So they give us some function. They say f of x is equal to 6x to the 4th plus 31x cubed plus 27x squared minus 191x minus 273. So they give us this really long function, and then they tell us x equals -3 plus 2i is a 0. Okay, so that's our given information. And then they ask us to find all remaining zeros. Find all remaining zeros. Now, we're going to use a couple of things. We are going to start with what's called the conjugate zeros theorem. And I'm going to put this over here on this right-hand side for you, okay? So we've got an imaginary, or what a lot of people will call a complex 0 here, right? So it's got a real and an imaginary part, a complex 0, okay? Now, complex numbers always have what's known as z bar, which is the conjugate. Okay, conjugate. And you found conjugates before if you're watching this video. A conjugate's where you just change the sign between the two numbers. Okay, and what the conjugate zeros theorem says, okay, conjugate zeros theorem says if a plus bi is a 0, a minus bi is also a 0. Okay, there is one catch. Okay, this is true if the coefficients are real numbers. Okay, if the coefficients are real numbers. Okay, so if I go back to my original equation, all of my coefficients have to be real numbers for this theorem to work. So if you were reading through here and there was a 27i, you can't apply this theorem. But as long as these are all real numbers, this theorem can be applied. So what we're saying is if this is a 0, then negative 3 minus 2i, which is the conjugate, is also a 0. So let me show you that. I want to prove it to you. So here's what we're going to do. We're going to take this polynomial and we're going to divide by this given value. This will be fun, right? So synthetic division, we're going to take our, and you need lots of room, I promise. Okay, so 6, 31, 27, minus 191, and then minus 273. Okay, we're going to come in here and that's our remainder. Okay, and we're going to divide by negative 3 plus 2i. Okay, and our first thing, we always bring this down. Okay, and I'm going to show you what I'm doing as I do it because this is a lot of work. So I'm going to multiply by 6. So it's just going to be 6 times negative 3 plus 2i. Okay, so I'm going to distribute that, and 6 times negative 3 is going to be negative 18, right? And 6 times 2i is going to be 12i. So that times that gives me that. I'm going to put that, right, this times 6, I'm going to put that right there. So minus 18 plus 12i. Okay? Now, real and real will add. So if I take 31 and I subtract 18, that should give me 13. And then, of course, because there's no imaginary part to this, it's going to be 0 plus 12i. Okay? So now I got to multiply this times this. And that's why I'm showing my work, because you're going to need to see that. Okay? So I'm going to say negative 3 plus 2i times 13 plus 12i. 13 plus 12i. Okay? And I'm going to use the FOIL method for this. So I'm going to say, right, negative 3 times 13. Okay? And that's going to be negative 39. And then negative 3 plus 12, that's going to be 36i. And then I'm going to say 2 times 13, and that's going to be, wait, negative 3 times 12 is negative 36i. Almost boo-booed there. And then 2 times 12i is plus 24i. And then 2i times 12i is 24i squared. Okay? That's 26. I cannot count today for some reason. 2 times 13 is 26. I know that. All right, now we're going to combine these like terms. Negative 36 plus 26 will give me negative 10i. And you got to remember, what is I squared? I squared is just negative 1. So I get 24 times negative 1. That's going to be minus 24. And so I get negative 39 and then minus 24. And that's going to give me minus 62. So get minus 62 minus 10i. So that's minus 62 minus 10i. Okay? And then what do? We add the real parts and we add the imaginary parts. Well, the imaginary part's 0, so 0 minus 10 is minus 10i. And 27 minus 62 is negative 36. So we get negative 36 minus 10i. what's our work going to show next? We're going to come down here and we're going to say negative 3 plus 2i times that guy. Negative 36 minus 10i. Okay, well, negative 3 and 36. Well, 3 and 30 makes 90. And then you add 18. So that's going to be plus 108. Okay? And then 3 times negative 10, that's going to be, right, negative 3 times negative 10 is going to be plus 30i. And then 2 times 36, that's going to be minus, 2 and 3 is 60, and add 12, so that's going to be minus 72i. And then 2i times negative 10i is going to be negative 20i squared. Okay, so combine these, right? So you got 72, and you're taking 30 from that, and you'll get negative 42i. And remember, this is negative 1, so that's going to be plus 20, right? Negative 20, negative 1, that's plus 20, so this will be 128 minus 42i. So this times that gives me 128 minus 42i. Okay? Cool. Crazy. Let's keep going. There's no way this adds up to 0, right? That's what you're saying. You're wrong. It does. Let me show you. Okay? So I'm going to squeeze in kind of over here on this side of my paper. So I'm going to squeeze in just right here on this side of my paper. Add those together, right? Negative 191 plus 128. And at this point, I'm going to use the pocket brain. Okay? And I get negative 63. Negative 63. And then 0 minus 42i is minus 42i. Okay? I need to multiply this number and this number. Okay? So, here we go. I'm going to take negative 3 plus 2i times negative 63 minus 42i. Okay? And negative 3 times negative 63 is 189. Okay? And negative 3 times negative 42i is going to be positive 126 plus 126i. Okay? Now, 2i times negative 63. 2 times negative 63 gives me, oh look, negative 126i. These two will cancel. That's interesting. Okay. And then the last one, 2i times negative 42i. Well, 2 times 42 is 84. So it'll be minus 84i squared. But we know this is negative 1. So 84, negative 1 makes plus 84. Okay. What's 189 plus 84? Well, 189 plus 84. Look what you get. 273. That's very interesting. So this guy times this guy gives me positive 273, and we get a 0. So, I didn't lie to you. I told you that this was a 0 of this function. We got a remainder of 0, so it is. What do we know now? We know now that the conjugate is also a 0. Do not use these numbers. That is a 4th degree polynomial. This is a 3rd degree polynomial. You're going to use these numbers. So I'm going to make a new synthetic division bracket, and I'm going to copy these numbers here. 6, 13 plus 12i, negative 36 minus 10i, and negative 63 minus 42i. Crazy. Now what? Now I'm going to use negative 3 minus 2i here. Okay, 6. Well, 6 and negative 3 makes negative 18, and negative 2i times 6 makes negative 12i. Those go away, and 13 minus 18 is negative 5. Okay, negative 3, negative 5 makes positive 15. Negative 2i and negative 5 make plus 10i. Those go away. Neat. Okay. Whenever you divide by a complex number and its conjugate, the second division should be really pretty. If it's not, you either screwed up the first one or you're screwing up the second one. Okay? So free advice if you want it. Okay, cool. So let's add these. Well, negative 36 plus 15, that's going to give me like negative 21. Yeah, that sounds right. Okay, cool. Now, what's negative 3 times negative 21? Well, that just so happens to be positive 63. And negative 2i times negative 21 happens to be plus 42i. And those go away, and you get a remainder of 0. Cool. Now, here's where we're going with this. Let's go all the way back up here. We started with a 4th degree polynomial. This answer is a 3rd degree because we divided by a single degree. That means this answer is a 2nd degree polynomial. Specifically, here's what we get. This synthetic division is equal to 6x squared minus 5x minus 21. Okay? Why is that important? Well, because I used synthetic division to get these first two. So I started with a 4th degree polynomial, right? 4th degree polynomial, did synthetic division, said, okay, this is a 0. Did synthetic division, said this is a 0. Now I have a quadratic. That's important because I can factor that quadratic or I can use the quadratic formula, okay? So you should know how to solve this. If you're watching this video, you've dealt with quadratics before. So if you think, okay, well, 6x squared minus 5x minus 21, I'm going to factor that. So this will be 3 and 2, and this will be 7 and 3, or, this will be 6 and 1 and 7 and 3, or whatever it is. Factor it. You'll get 2 more answers. If you can't factor this and use the quadratic formula, right? This is A, this is B, and this is C. You plug them in, you'll get the other 2 answers. Now, you're done. You've got the 2 answers from synthetic division, and then the 2 answers from here. Bam, there's all of the zeros. So I hope this video helps. I hope you're able to figure some of these things out if you're in a class where they're doing this stuff. And if you have questions, let me know.